Hello, everybody. Welcome to the StatSlice webinar in Cloudera Impala. My name is Brett Neuman. We're going to go ahead and get started here. This webinar is a continuation of our Big SQL Analytics webinar series. If you joined us last month, you heard Bernard Webby talk about Amazon Redshift. Today, we'll be looking at another Big SQL implementation and comparing the two. First, a little bit about StatSlice. We are a business intelligence consulting firm from Dallas, Texas. We have partnerships with several BI software companies like Microsoft, ClickView, Tableau, and Roam BI. We specialize in data warehouse implementations, dashboard design, analytics, and general business intelligence training. For more information about the services we provide and the partners we work with, please visit our website at statslice.com. This webinar series is focused on alternatives to big data. We are examining all the different options out there in the marketplace and trying to demonstrate our results so that our clients can make better informed decisions on which platforms would work best for their needs. Our previous webinars that we've given have examined query performance from Redshift, as well as connecting Redshift with Tableau. You can find several blog entries on this subject, as well as articles on our website. We have several more articles and webinars planned in the near future, looking at platforms such as Vertica and Hortonworks, Stinger, and the latest Hive release, along with Pig and others. In this webinar, I'll be giving you an overview of Cloudera's Impala platform and how you can use it in your business. We will present a customer case study similar, or almost exactly like our last webinar, and compare query results with Impala and Redshift. Lastly, we'll follow up on the limitations and what we found that appeals to us about Impala and discuss some architecture implications. So before we talk about Impala, I first want to make sure everybody understands what Hadoop is. And Impala is built on top of Hadoop. Hadoop is an open source big data platform, which means massively parallel servers processing huge amounts of data across inexpensive standardized hardware. Hadoop uses what they call the Hadoop distributed file system. I'll refer to it here as the HDFS. And that automatically distributes data across multiple nodes for higher performance. Impala is a SQL engine written by Cloudera that works within the existing Hadoop platform. Impala was designed mainly for analytical purposes and is highly scalable. It runs directly within Hadoop and doesn't require any specialized hardware to run on. It was written in C++ instead of Java for the best performance, and can read directly from the HDFS, which means that it bypasses the data nodes for increased query performance. Since it doesn't use MapReduce, it ends up being hundreds, possibly, times faster than the traditional Hive. Continuing with Impala here, Impala itself is a fully distributed system, which means that you can start a query on any node in the cluster that you want, and that node becomes the executor or coordinator node. That node is responsible for delegating the processes and pulling data from all necessary nodes. You can submit queries using existing query tools like ODBC or JDBC. Today we'll be looking at querying Impala via the Hue web interface. There's also, of course, an Impala shell that gives a command line interface for queries. Impala supports many different file formats, specifically text files, and supports compression, and it also supports Parquet files, which is a new columnar storage format that Hadoop is pushing out. It's not something I was able to investigate for this particular webinar, but something we'd certainly like to circle back around to and show you more about in the future. What really separates Impala from Redshift is that it uses a big data platform to store its data. Basically, when you create a table in Impala, you can simply tell that table where its data is on the HDFS cluster, and Impala will treat it automatically like a populated table. No insert command is really needed there. So the time it takes to populate a table is just the time it takes to upload the file. Also, since the files are stored on the HDFS, they're already replicated across multiple nodes, and that's really where the performance comes into place. So the way Hive's metadata manager looks at tables is by folders. Now, this is very interesting. So one folder equals one table. One folder can hold multiple files. Just as long as all the files are the same format and structure, it will append all the data together and view that as a single table. This makes it really easy to append data on a daily basis. So you just upload the new file and it's ready for analysis. So why consider Impala? Why not just stick with your current solutions? More and more companies, not just large, but medium and small companies, are dealing with larger and larger data sets. This data can come from legacy systems, or in the scenario that I'm going to show you today, large data sets can be used to provide very effective predictive analytics. What do companies do with historical data these days? They can compress the data into SQL backups. They can use tape drives, but all this leaves the data fairly inaccessible. You might as well just delete it, or better yet, print it out and put it in filing cabinets. Instead, the solution really is to store data where you can access it. Your options might be a SQL Server database that has tons and tons of storage, but in order to manage that, you'll have to hire DBAs and tune the system and take care of the system if you ever want to use it. Now, on the other hand, big data could be the answer, right? But the problem with big data is that you have to learn new tools. You have to learn MapReduce and other ways of accessing your data. You really have to retool the existing infrastructure in order to utilize big data in the way that it's intended. Another option, of course, is the massively parallel processing appliances, right? The MPP appliances like Teradata, Greenplum, Netezza, but these tend to be prohibitively expensive unless you're a really large company, right? So the answer could very well be a big data style storage mechanism with a SQL-based tool on the front end. This is exactly why we've been investigating Impala. We want to see if Cloudera has come up with a viable Big SQL option. So let's take a look at our customer survey, our customer case study here. This is the same case study from last month. So we'll just glance over this real quick. Our client would like to predict costs out over the next 10 years based on their current sales figures. They're not quite sure which segments of the data set they'd like to look at. They don't know quite what their analytics are going to be. So like most companies, they'd like more of an ad hoc environment to query their data. And so what they're going to want to do is to forecast out their projected costs over the next 10 years. And if you do the math on that, they have 10 million customers. Each customer has about 10 products. And over 10 years, that's 120 months. When you add all that up, that's 12 billion records. Now, traditional database systems might be able to handle between 50 and 75 million records fairly effectively. But once you get too far beyond that, it becomes a nightmare to keep up with the partitioning and indexing needed so that you can query your data set in a reasonable time. So what we're going to do is to determine if we can create our data set on Impala in a reasonable amount of time and see how long it takes to run certain queries on that data. For our test, we've come up with a subset of this data set. We're really only looking at 10,000 customers instead of 10 million, which is going to knock our data set down to about 1.2 or 2.4 billion records, actually. So it's a little bit more manageable sum for this particular webinar. But you should be able to get an idea of whether Impala can stand up to our test. Just like Redshift, we're going to show that Impala scales linearly. As the number of nodes in the cluster grows, we will see a comparable increase in query performance. This really should be expected from all big SQL platforms out there. Firstly, before we get into a demo, I want to talk real quick about installing and configuring Cloudera. The largest difference between Cloudera and Redshift is the fact that you can install Cloudera yourself. Redshift really is a cloud-based big SQL platform. All you have to do is sign up for it and it's ready to go, whereas Cloudera is software that you can download and install yourself. Cloudera has made installing Hadoop almost as simple as installing Redshift, except that you need to use your own hardware. For this demonstration, we used Amazon EC2 instances to build our own cluster. We did this for two reasons. Firstly, Cloudera integrates with EC2 very effectively, which means that we can set up a test cluster and only pay for the time that we need to turn it on. And secondly, Amazon was used for both the Redshift proof of concept and Impala here, so that we can show you a neat little price comparison in the end. To install Cloudera, you will first need an instance for the manager. And this is an important piece because a Hadoop cluster can tend to be complicated to manage, but Cloudera's management system makes it nice and simple. You can put the manager on a relatively cheap node, like an M1 large, which we did here. It does require some simple Linux commands in order to download and install the manager. So you do need to know a little bit about Linux. But once the manager is installed, adding hosts and configuring a cluster is very easy. Cloudera provides what they call the Cloud Express wizard, which will pop up as soon as you log into the manager for the first time, and the wizard will recognize the fact that it's been installed on EC2 and give us prompts for adding nodes to our existing EC2 environment. All you have to do is tell Cloudera how many nodes you want and give it some credentials, and in a few minutes, we're up and running. So let's get into a demo and see a little bit about Cloudera. Let's see. There we go. Okay, y'all can see my screen now. This is the Cloudera Manager website. After you install it, you come to port 7180, and this web service is already up and running. And you can see on the right-hand side we've got our some graphs and stuff about our bandwidth and CPU usage. But what's really important is on the left-hand side, we have our stoplight dashboard for all our various services that are in the cloud. This makes managing this cluster very nice and simple. We can see that HDFS is one of our main services, and it's right there available. We've also got Hive, which is our metadata manager. Impala, of course, is what we're talking about today. MapReduce is the generic way of accessing big data. Uzi is a pretty interesting workflow manager that we're going to come back around and examine for you guys. And Scoop is an effective way of pulling in data from a relational SQL database into Hadoop. So there's some tools there between Uzi and Pig and Scoop to help us bring data into our system. If I take a look at the HDFS node, which is really, that's our file system, you can see that it gives us a nice summary of HDFS. And let's see, I'm waiting for the screen to catch up with me. looks like there's a slight delay in the website showing up. Okay, so this is our overview of HDFS, and you can see all the statistics that Cloudera provides for you. And we can see immediately if there's any problems with the HDFS cluster. Certainly we get error messages of under-replicated blocks, and what HDFS is really telling us here is that it wants 3 nodes, and I've only set up a 2-node cluster. So I did that on purpose, for us to save costs. So when you set up your own cluster, just note that Hadoop is going to yell at you and want 3 nodes. So not a big problem. What you can see from the main screen here is that it will give you a high-level view of any problems that we have. And what this is saying, of course, is that it wants 3 nodes as opposed to 2, and it's just a warning. It's not a huge problem. You can also manage your hosts from this website. And right now you'll see that I have just 2 hosts here. And if I wanted to add an extra host, I can simply click this button right here, and it will launch the Cloud Express wizard, which I was talking about earlier. So this just steps us through creating a new node. And you can see that it immediately recognizes that we're on an EC2 instance, and it's going to want to add new nodes to that. It allows me to select what size node I want, and then the next screen would ask me to log in my credentials and then launch, and within a couple minutes you've got a new node. So I won't go into that too deeply here. Just wanted to give you all a brief overview of how the Cloudera Manager works. One thing I did want to show you here was another service called Hue. And Hue is a pretty interesting web user interface that allows you to actually interact with your cluster, right? As opposed to just scripts and command line interfaces, Hue is going to give us a web view into our cluster. I can do things like look at the files in my HDFS. I also have many different ways of actually querying the cluster. We can use Hive and MapReduce, or Impala and straight SQL, or Pig, which is a language that we're going to revisit here in future webinars. So first, let me examine the file system and show you where that database actually gets stored. We do use Hive. We go through Hive in order to create tables. So Impala kind of piggybacks off the metadata manager that was implemented by Hive originally. So there's a lot of similarities between these languages. But you can see in the Hive warehouse folder here, I have a database that I created called Demo. And what it does is create a folder for each individual table. So here you can see by tables. And if I take a look at products table, you can see the CSV file, which I just uploaded this file myself. I just hit this upload link over here in the top right corner and uploaded a file and shot it in there, and it took just a couple seconds to upload this. Of course, it's a pretty small file, but you can see that we can take a look at it, and it was immediately available for use as soon as it was uploaded. Another interesting folder to look at is the sub-report folder. This is really my large fact table. And what I did was I inserted data into the table here that was created, and I did it twice. And so what it's done is it's created 2 files for me, and both of them are about 20 gigs in size, and they all have a similar structure. So these 2 files are appended together and become the data behind our table. So I just wanted to give you a view into that real quick, and now we'll flip over and show you how Hue can be used to query Impala. This is a simple interface into querying Impala. I can select my database from the drop-down list here, and I can say Show Tables and get a view into my metadata. There's my tables. I can flip back to the query editor and actually execute a query if I'd like to. So please select star from product. And you get a nice little pretty formatted output here. The other things that you can do with this interface is actually store queries on it. So I have a couple of scripts that I created and just saved here. And you can see that this is my script that I use to create my tables. So very easy SQL that we're using here, fairly standard. It's almost standard. We create database, and then we create the table just like you normally would, except instead of just ending it there or tell what file group we're associated with, we actually tell it the format of the file. So you can see right here, I say row format, limited field terminated by comma. That means comma separated files, and then I tell it where that file is located. And as soon as I hit that command and execute it, the table is prepared and ready for me. So I think that's pretty fairly nice. So the other script that I have here is our actual demo script. And these are the actual queries that I ran for our test. You're going to see that they are very much like the test we gave last month, sorry. And we have insert statements and delete statements, and then we also have our actual queries. I'm going to show you some of our more complex queries, which you'll see just the results, just how long it took to run these queries. But this query, looking at test 9 here, we see that we've got a join to a second table when we've got a complex where clause. So, we're not just doing select stars. We're actually putting a little bit of logic into it, not overly complicated, but it gives you an idea of what some of our queries look like. So that's our view into Cloudera Manager. It is free to download and install and try yourself, so I would encourage you to do so. And we can always revisit that later on. So what I'd like to show now is our actual results from some of our queries. So the first thing we did was we tested inserting into a table. And when we tested the inserts commands, we found some very interesting behavior with Impala. Our insert statement used a cross join across 3 tables to create a 1.2 billion record set. Now, cross joins aren't readily available in Impala. It's actually not implemented just yet. So we had to fake it, and we created an extra field that we just populated with 1s for all tables, and we joined on that, and that allows us to simulate a cross join. And what we found out when we did do the insert is that it took almost 30 minutes to insert 1.2 billion records into that table, and that's on a 4-node cluster. What was even more interesting is when we performed it on a 2-node cluster, right? We were talking about linear scalability. As we dropped down to two nodes, we expected it to take an hour, but we ended up getting the exact same results. So what it appears is that when we insert records into a table, we're using Hive to write that data to a single file on one HDFS node, and then the data is distributed. So you are getting, multiple writes in there, but it looks like it's, a single point of execution as opposed to distributed across all nodes. This means that either the inserts aren't benefiting from the parallel architecture, or Impala is simply not optimized for inserts at this point. I did attempt to research the behavior, but we weren't able to find any documentation from Cloudera explaining it. But what I was able to find was the fact that Impala can only insert data into a table when using text or Parquet formats, right? Parquet was the columnar format that we're talking about. So inserts only supported on text-based files. In other file formats, you have to use the other Hive language directly, so you have to use beeswax in order to insert. So what that really means is that Impala just isn't fleshed out enough quite yet, to act for inserting into binary files or sequential files. What it seems like is that Impala acts like a big data engine in this respect, meaning that what it really wants you to do is upload new files to the table, and that appends data automatically. Cloudera does make it rather easy to do this, but it may require a small bit of retooling in order to use that, as opposed to normal inserts that we're all used to. In future webinars, we, of course, intend to explore different methods for inserting data into Cloudera, like Scoop or Pig, or even using MapReduce to produce our data sets. In addition to inserts taking a long time, we can see that appending data takes about the same amount of time, and it's really just performing the same action, so that's expected. What's really interesting is the update test. There isn't an update command, of course. So instead, what we have to use is the insert overwrite statement. What happens is Impala seems to read the table from all available data nodes and then write to a single temporary file. And then after it's done, it swaps those files back out. And so you've really got a fairly complicated update statement, which makes updates almost unusable. But since it can read from multiple nodes at once to get the data set, it does write a bit faster. So the insert overwrite command can take less time. But the results are still not very promising. Deletions are very similar to updates. In fact, Impala doesn't actually support deleting a single record from a table. Instead, you use the insert overwrite command again, and you have to create a clever where clause to exclude the record that you wanted. So in my mind, this almost takes Impala out of the running to be called a Big SQL platform. If it really wasn't for the other query performance that we're about to see, we almost couldn't see the merits of using Impala at all. But here are the results from the select statements. Now, these tests are the exact same tests that we ran on the Redshift cluster last month. Again, we ran these on a 4-node and a 2-node cluster. You can see the results are actually in seconds and not minutes, like the insert statement, so a lot more promising. These queries were run against 2.4 billion records, so once we did actually insert all the records, we ran it on that final result set. You can certainly see the linear scalability at play here. Most queries on the 4-node cluster took between 25 and 40 seconds, while those same queries took between 40 and 70 seconds in a 2-node cluster. Now, if we look at the large cluster results versus the large cluster results here versus the Redshift results over here, we can see that for the most part, Impala may actually be faster. On average, Impala seems to be about 10 seconds faster on this particular test. Of course, these are very unscientific tests, but you can get a feel for how Impala would perform in some situations. Now, like I said previously, since we were able to install Cloudera on an Amazon cluster, we were able to compare monthly costs between the two systems pretty easily. First, you'll notice that Redshift does come to about $1,000 per terabyte per year, while a single node Cloudera cluster is slightly more than that, just a little bit more. This is mainly due to the overhead of the manager node. When we looked at a 4-node cluster, we saw a little bit more separation in price, but only in the upfront costs of reserved systems. A 4-node 3-year reserved Redshift instance will cost you about $12,000 on the first day. as opposed to about 10,500 for a comparable size Cloudera cluster. In the end, cost really isn't going to help you make your decision here. Cost would really only come into play when you're looking at what it would cost to install Cloudera on your own hardware. When you have to consider depreciation of assets and all the fun accounting that goes along with that. So, in the end, we don't believe that Impala can really compete with Redshift in a head-to-head test here. When we think of Big SQL, we want a tool that can completely replace a traditional relational database, not just parts of one. There's really no way of avoiding a bit of retooling on your team if you want to incorporate Impala. You would have to look at using MapReduce or Pig to load data in parallel before you can perform your analyses. Due to that limitation, Impala can only complement a traditional relational database system in your architecture and not completely replace it. Luckily, Hadoop is an open source platform, and Cloudera is an excellent software company. We look forward to seeing how Impala evolves over the next few years. You can certainly look to StatSlice to follow up on Impala once we think it's ready for prime time use. The limitations here are pretty obvious, right? Insert updates and deletes are a no. That's a pretty big loss. Also, table order and a from clause is important for optimization. This is not a big deal, but you really need to put your big tables up front and your small tables on the bottom of the where clause, and order them appropriately. Otherwise, the SQL engine will not perform very well. Not a huge loss, but it is an issue. Also, no cross joins. Also, not a big issue, but it illustrates the fact that Impala is still in early stages of development. There are many other SQL language elements that are not implemented just yet, but I won't go into all of those here since they're prone to change very quickly as Cloudera implements, new language elements. You can certainly find a complete up-to-date list on Cloudera's website. One more very important limitation here is the lack of stability. If one of the Impala nodes goes down during a query, that entire query will fail. This is due to the way Impala delegates its queries. Whichever node you connect to run the query becomes the coordinator node and delegates tasks to the other node. If one node fails, the coordinator doesn't have a backup to take over that task, so the entire query goes down. Cloudera says that they forfeited stability for performance here, which is always a plus. We're looking for performance, but we're not sure if that was a great choice, especially for a production environment. All it really means is that Impala is still very young, and Cloudera is looking to add automatic failover to its nodes in future releases, so we'll be on the lookout for that update. Now for the upside. Impala does show a lot of promise. Appending data by uploading a new file to a folder is very easy and quick. The data is ready almost immediately, and it's appended much faster than a SQL insert statement. Linear scalability is confirmed. That's pretty much a necessity when talking about a big data platform. And it's fairly inexpensive when compared to more traditional massively parallel appliances, especially if you're going with your own hardware. It can be inexpensive. And the Cloudera Manager provides a very easy interface to manage your cluster, so it requires very little maintenance. It makes it easy to add, remove, and manage your nodes as opposed to manually installing Hadoop and using a command line interface, which would be much more difficult. Lastly, of course, you can install Cloudera on your own hardware, on any hardware. This puts more control back into your hands and can increase cost savings. In conclusion, Impala really only works for analytics not so much in our scenario of predictions or predictive analytics or trying to generate large data sets. We would really only use Impala if you have already decided to go with Hadoop. Otherwise, there's really no compelling reason at this point in time to add Impala. And if you want to stay with the SQL platform, certainly look to Redshift. Right now, that's our current answer. But we do encourage you to go out and investigate your own, proof of concepts and proof these out and how they work in your own implementation. Certainly consult with companies like us who are doing these investigations. And stay tuned to our webinars in the future, because we'll do the investigations for you. We'll show you what's good, what's bad, and how it might fit in with your architecture. So thank you, everybody, for attending. My name again was Brett Neuman. If you have any questions, or if you'd like to contact us to request certain software platform investigations or whatever, we'd love to do that for you. Certainly contact me directly at bneuman@StatSlice. And thank you all for attending. I'm going to take a look